Okay, I'm going to introduce you to parallel circuits. So in a parallel circuit, the resistors lies in parallel. So what's going to happen is the current actually splits up. Okay, as you can see, there's a junction, and the current splits up to each resistors, then come together. Okay, so okay, now say if I have three resistors, 100, 200, 300 ohms. Okay, the equation we're going to use is V equals to IR. So the important thing in parallel circuit will be the voltage. Okay, the voltage across each resistors are the same. Okay, so V1 equals to VR, V2 equals to V3. Okay, and um, okay, the total resistance, okay, the equivalent resistance will be given in a different formula. It looks like this. Okay, now the power of -1 is a mathematical symbol. Okay, basically we can, well, we can reflect fraction. Okay, so um, if I have a fraction 3 on 7 power of -1 will be 7 on 3. So yep. Okay, now now let me ask you a question. Okay, so suppose we need to find the current across resistor 1, the current across resistor 2, and the currents across resistor 3, I1, I2, and I3. Okay. Now, as we can say, the total current will be the sum of all these three. Okay. And yep. Okay. Now let's do this question. Okay. So what we know is the voltage across each resistors will be the same. Okay. It will be 12 volt. Okay. In a parallel circuit. Okay. Now use the equation V equals to IR. We can find the current. Okay. Rearrange it. Okay. We can find the current of each. So I have 12 divided by 100, 12 divided by 200, and 12 divided by 300. Okay. My answer will be 0. Okay. Now that's basically I1. The current goes through. Okay. So just let me label it I1, I2, and I3. Okay. So by adding them up, okay, I have the total current. Okay. The current here. Okay, will be the I total. Okay. Also here. Now, this is one way of doing it. Okay. Because we know the voltage. Um, well, how to, sorry. Okay. This is one way to do it. Okay. Now, let me show you another way to do this question. Okay, just let me, well, calculate the total current first. Okay, if I add them up, it will be, well, let me write it down. Okay, plus 0.06 plus 0.04, it will be 0.22 amps. Okay, so I have 0.22 amps here, and I have 0.22 amps here. Okay, when it travels to the junction, it splits up to 0.12, 0.06, and 0.04 amps. Okay. Yep. Now, okay. Now the other way to find the total current will be still use the equation. Okay. Now this time, let's analyze the whole circuit in a analyze the whole circuit. Okay. So instead of resistance, let's find the equivalent resistance. Okay. Remember, equivalent resistance means the total resistance. Okay. Using the formula here. Okay. So 100 plus 200. Oh, sorry. 1 200 plus 1 300 bracket power of -1. So you can use your calculator, but I prefer to do it by hand. Okay. Okay. Actually, sometimes I make mistakes. Okay. Then use your equation V equals to IR, I equals to V divided by R. So I know this is a little bit, it's not easy. It's not easy as the previous question. However, you need to be able to do this with a calculator in the exam. Okay, for year 11 and year 12. So we have the total. If you do the math, it should be the same, 0.22. Type it in your calculator. Amps. Okay. So the idea is you're going to find your answer either ways. Okay. So you need to be able to know how to do that in both ways. Okay. However, in the exam or when you're answering question, just choose the easiest way to do it. Okay. Now, the other thing I would like to show you is now the idea of the equivalent resistance. Okay. Now, because we found the equivalent resistance is 600 ohms on 600 on 11 ohms. Okay. So what we can do is sometimes engineers or scientists they can rewrite. Okay. They can rewrite this circuit in a simple form. Okay. So what they can do is they can redraw this circuit in this form. Okay. Instead of 3 parallel resistance, okay, they can use a single resistance RE, okay, and indicate RE will be 11 on 50 ohms. Okay. And these two circuits, if you have a look, they means the same thing. Okay. Just depends on the application, the engineers and the scientists do this to make everything simpler. So yes. Okay.